Alright, let's take a look at what... Oh, there we go. Oh. I'm not going to, because this is another abstract class, so we don't actually want this guy in common either. So we might be making yet another interface. Let's move this guy back. Alright, you're happy again. We'll deal with you in a second. Oh, that's my bad. These are all abstract classes. So, we're going to do this a kind of easy way. We're going to copy this. Alright, now just bear with me. Send these guys back to where they came from. There's a chance we're not even going to need these, but public interface, player keepsake, I, inventory types. So it gave me this prompt. Are you renaming a file that's from the same renamed product and all references? No, because it was hard to see, but I copied that, and so there was two classes with the same name, and I don't want it to go running through everything and making some mistakes. We've got enough to deal with right now without making that a problem. Okay. So I think we've moved everything back that we wanted to. Common domain, player weapon. Is that the right one? Yeah. iPlayer, equip weapon, equip wearable. Oh, okay, so we want this to be I and that to be I. Okay, so far so good. Don't get me wrong, it's going to require quite a bit of testing, but we're getting closer and closer. Right? How's it looking? I think pretty good. Okay, hang on real quick. Got something in chat. Alright, so this is actually a good question, and it plays onto something we were talking about earlier. Tiffany Anthony says, I've had something on my mind recently. Hear me out. I recently did my C++ exam at school, where we had to make an insane exercise with lots of classes, inheritance, pointers, etc. I think it's insane how people can keep an overview of such a project to a point where they know exactly what to fix if something goes wrong, just like you're doing now. You're having no problem finding the exact files you need to fix something. I think that is something really cool for a programmer. What do you think about this? Sure. So I think the concept is the personal software process. One of the big reasons to go through and do katas. So you go back to the previous weeks and videos and you see the way that we approach doing the bridge pattern and the command pattern. It adds a style to your code. You figure out the way that you want to do certain things. And even though we covered quite a few katas, if you look at the code, you can start to train your brain to recognize your own patterns. And you can say, oh, I was doing a strategy pattern here, and consistency is key. So I know that whenever I do a strategy pattern, the code's going to be located in this this area of the program. So once you get an application that has 5, 6, 7 design patterns, and you've been practicing your katas, you can usually crack it open. If it's yours, mind you, usually crack it open, and you can start to retrace that mental map, because all it is it's just the architecture, right? It'd be the same thing as saying that a building is very big. How do you ever remember on any given floor where the fire extinguisher is? Well, you've got a plan for that, right? You know that on any floor in any building that you've designed, you always put the fire extinguisher in, a certain location. And so it's the same thing here. And that's why doing the katas is so important. And it's also the only thing, and this is why when we first started this, we had like 3 files. It's the only thing that's going to keep you from going mad. I promise. Okay, let's start looking around for outfit. Weapon. Oh. So ReSharper tried to make some aliases for us. And we said, no, thank you, ReSharper. Okay, so let's get some red stuff here because our weapon interface needs a few more things. So our player weapon is inheriting from player inventory item as well as iPlayer weapon. If you go to player inventory item, it's inheriting from iPlayer inventory item. So here's where inheritance gets pretty wackadoodle. So stick with me. I want iPlayer weapon to expose everything that's also in iInventory item. Right? Let's get rid of this guy. So we said, hey, iPlayer weapon is really just a fancy way of saying iPlayer inventory item. And so that way when we go to our player weapon, iPlayer weapon says, hey, I've got 2 contracts I need to satisfy. And as we move forward in our inheritance here, it's going to say, okay, one of my contracts is satisfied by this base class. and then the other one is satisfied by either this class or the inheriting class. So probably one of the more fun ways to use inheritance, where you really want to make sure your things are being composed properly. I'm moving through it kind of fast because I know we discussed that a lot in previous videos. Alright, so this should all be looking better. Outfit. Let's go back up to outfit. We have to do the same thing for iWearable. So iWeapon, iPlayer inventory. Let's go back over here. I'm sorry. To this guy. Player wearable. It also inherits from player inventory item. And we want to say iPlayer wearable should also inherit from, oops, that guy. And we're adding anatomy onto that. Alright, so this actually looks really good now. Whew. We did quite a bit of refactoring there and adding some interfaces, and we should be really proud of ourselves. So we got to go to our classes now and fix that guy, because that guy's now in our common. So holler at your various boys. We were really good. You and I. Us. We're good. Okay. Let's look at our classes, because if Army Vet's messed up, yep. And all we're doing is just saying, hey, the thing that you're looking for is now in a different assembly. So let's go ahead and change those references around. Tisney Anthony says, exactly, because just imagine working hard on such a task and suddenly you get a sort of blackout and you lose your overview. I would literally go insane. Yeah, you aren't the only one, buddy. We call that and so in the kind of paradigms of programming, there's this saying that as an application grows in complexity, changes to that system become exponentially more difficult, right? So it's saying, as you grow and grow and grow, what used to take 2 hours to change now takes 4. Then you grow and grow and grow. Now what used to take 4 takes 16. And you grow and you grow and you grow. And now what used to take 16 takes 32 hours. So this increase in the amount of time it takes to make changes to a system, to find bugs, to extend the system, that as that takes longer and longer for the same type of task, we call that technical debt. So you naturally accrue, or you naturally gain technical debt for the longer the system is in operation, and the more changes you make to it, and the bigger it becomes. You're constantly increasing your technical debt. You can't slow this, right? So you can't stop it. All you can do is you can slow it. And so making sure that everything you do is very consistent is one way to slow that technical debt. All right. Man, oh man. You see that? 200 errors. I think that's wrong, though. I really, really do. Because all this is right. We fixed it.